Welcome to Kenton's videos. Enjoy the video.
You begin by finding the two consecutive perfect squares that enclose the range. For example, n2 and n plus 1, 2. Calculate n by the integer square root. Once done, compute n plus 1, 2 to set the upper bound. Make sure to list integers strictly greater than n2 and strictly less than n plus 1, 2. You do this because the spacing between consecutive squares gives a predictable count. This simple step converts a vague range. Next, generate the sequence from n2 plus 1 up to n plus 1, 2-1. Write or type them in a column for clarity. You should verify each candidate isn't itself a perfect square, compare to K2, or use quick checks like parity and mod 4 patterns to catch mistakes. Once done, count the items. It will equal 2n, which confirms your work. Make sure to check in points, because off by 1 slips are the usual source of error in this step. To finish, confirm the final list length equals 2n, where n is the lower square root. That proves completeness. If the count is wrong, go back and reevaluate n, the endpoints, and look for off by 1 errors. These are the most common problems. Make sure to use a calculator for large numbers to avoid arithmetic mistakes, and if a number looks suspect, check it against nearby squares. You'll then have a reliable set and a quick troubleshooting method if things go wrong.
Thanks for watching. Consider subscribing if we helped you.